Okay, today we're looking at graphing linear functions. This is just 1.2a, so we're going to split this into two sections. And a linear function is a function that is an algebraic equation, and the graph is a straight line. And we talk a lot about their slope and their y-intercept as two key features that we're looking for when we're graphing these. So the slope is just your rate of change, and that is kind of like we talk about it being the steepness. A lot of times you'll hear with slope that it's the change in y over the change in x, or rise over run is what we'll talk about. And the y-intercept is where it crosses or intercepts the y-axis, and that happens when y is 0. So when we're looking in that. So one way we can graph is with a chart. And when we're doing a chart, you're going to pick some values, and then you're going to plug it into the equation and find your y value. So easiest to pick some x values, and usually we just try to pick some like lower numbers so we're not graphing way off the chart. So I'm going to pick 0, 1, and -1, and then you're just plugging those each in to solve for y. So y equals -3 times 0 plus 6. So y equals 6, because 3 times 0 is 0. And then we're going to plug in 1. So y equals -3 times 1 plus 6, which is -3 plus 6. So y equals 3. So I plugged in a 1, I got a 3. And then we'll do the same thing with -1. So -3 times -1 plus 6, positive 3, because two negatives make a positive, plus 6 equals 9. So now I have 3 points. Notice this is my y-intercept. Because that's when x is 0. So 0, 6 is 1 point. 1, 3 is 1 on the x-axis, up 3 on the y-axis. And -1, 9 is -1 on the x-axis, and up 9. So we have our 3 points. And we learned in geometry that we really actually only need 2 points to make a line. But for this part, we're going to do 3. So when we are determining whether or not it is a line, you should have a slope and a y-intercept. And your variables on your x or y shouldn't be greater than 1. So my variable here is 1, and variable here is 1. So yes, this is a function or a line. This is not, because this squared, x squared term makes it not a line. So this would be no. All right, so looking at a table to see if it represents a linear function, what we're going to do is check to see that the slope stays the same through all of that. So remember, slope between 2 points is the change in x and the change in y. So the x's are changing by 1, positive 1, and the y is changing by positive 4. So this slope is 4 over 1. And we're going to look here, we see change of here is 1, change here is 4. So again, slope is 4 over 1. And between these two, change is 1, change here is 4. So the slope is 4 over 1. So since all of these slopes are equal, then yes, this is a linear function, because the rate of change is staying constant, and your slope should stay constant in a linear function. Looking at this one, change here is 1, change here is 3. So my slope is y over x, 3 over 1, change in y. Change here is 2, and change here is 6. So my slope between these 2 points is 6 over 2, which still equals 3 over 1. So that's the same. Change here is 1, change here is 3, so my slope is 3 over 1. So yes, this is a function because, again, the slope is the same. But we need to be aware that when that change is different here, it should change the difference on the y too. All right, so when we're finding the slope of a line, like we talked about, it's your steepness. So it's how much you go up or down, the rise over run, or sometimes we call it change in y over change in x, which that's just what this delta signal, delta means change. So that's just the same thing, but with symbols. So when we're finding the slope, we're going to find our change in y over our change in x. So we're going to do -2 minus a -12 over 15 minus 5. So we see that is 10, because 2 negatives make a positive, over 10, which equals 1. Here, we would do 6 minus 21 over, so my y's, over 14 minus 14. So we've got 15, negative 15 over 0, which is a no solution, or it's an undefined slope in here, or because one can't divide by 0, so it's undefined. So when we have 0 on the bottom, it's undefined. If 0 is on the top, then my slope is 0, and it's just a horizontal. So this would be like a vertical line. If you're looking at a graph, you would see horizontal slopes have no steepness, so their slope is 0 because it's not going up at all. Vertical slope is an undefined slope because it is straight up and down, or an infinite slope. So let's look at these. Slope line A here. We're looking at their slope, so we want to make sure we get 2 points that are right on the corners. So right here we can see it's going down 1 over 1. So my slope is -1 over 1, or just -1. And my y-intercept is right here at 0, 0. My slope of B is this blue line. And again, you want to try to get where it's right at the corners. So it goes up 1 over 1. So it's a positive slope, or we can reduce that to 1. And the y-intercept is right here, and that is the point 0, 1. And then C, there's no slope, so my slope is 0, and my y-intercept is 5. So 0, 5. This point right here. We can also graph by x-y intercepts, which is super easy if we are in standard form. So this is called standard form, where we have the x and y terms on the left side and the equals on the other side. So that makes it super easy. So to find my x-intercept or y-intercept, that's when x is 0. So I would plug in 0 for the x. So that would get rid of that x term, and I'd have -2y, because we have 3 times 0, which is just 0. So I have -2y equals 12, and then I can solve for my y. So y equals -6. So when x is 0, y is -6. And then for my x-intercept, that's when y is 0, so we plug in 0 for the y term. So I would have just the 3x minus 2 times 0, that's just going to be 0, equals 12. So I just have 3x equals 12. So I divide by 3, x equals 4. So then I can just graph those with the intercepts. So 0, negative 6. And 4, 0. And then through any 2 points, we can draw exactly one line. All right, so we got some fractions here. If our intercepts are fractions, it's a little bit hard to graph. It's not totally impossible, but this shouldn't give us fractions. So remember, x-intercept is when, or y is 0, so, or y-intercept is when x is 0. So I would put 0 in for y, and that, or excuse me, 0 in for x. So I would just have my y term. So 1/2 y equals negative 1. And then I'm going to multiply by 2 over 1 on both sides to get rid of that fraction. So I have y equals negative 2. And then for the x-intercept, that is when y is 0. So I would put in 0 for y. And I would just have 1/3 x equals negative 1. So we're going to multiply by its reciprocal. So divide by a fraction, you multiply by the reciprocal. So I get x equals negative 3. So 0, negative 2, and negative 3, 0 are my 2 points. And then I can graph that line since I have 2 points. All right, that is where we're going to go right now. And we will finish up the rest on the next video.